Welcome to the second session of the lecture series of Transformers. I'm Tahlila Naveed from Luck Job Academy Skills. So till now, we have learned about the needs of the transformer and its uses. Now in today's lecture, I'll be explaining you the construction and the working principle of a transformer. For an electronics student, it's really very important to know how a transformer works and what is it made of. So if you'll be focused, it will seem easy to you to understand the things. After watching this video, you'll be able to know what a transformer is, why is it called a static machine, and what is its working principle and what is its construction. A transformer is a static machine used for transforming the power from one circuit to another circuit without any changing frequency. Here, two questions may arise in your mind. The first one is that, why is it called a static device? And how is power transferred at the same frequency? Now first understand that why is it called a static device? The transformer has no moving parts like motor and generators have. The complete transfer of power from this circuit to this circuit takes place without any rotating or moving part. This is the reason we call this machine a static machine or a static device. Now let me make you understand the working principle and the construction of the transformer with the help of these images. As all of you must be knowing that there are two types of electricity, the AC and the DC. But the transformers can work only with AC, that's the alternating current. So, if you don't know the difference between the two, please recapitulate the basics of AC and DC and then watch this video. When an alternating current flows through a cable, a magnetic field gets created around the cable, and that magnetic field is alternating in nature. The intensity or the magnitude of the magnetic field continuously changes. And when a DC current is flown through the same cable, the magnetic flux or the magnetic field created around the cable is of constant nature. And now, if we'll put multiple cables together and pass current through them, then the magnetic field would combine to produce a stronger magnetic field, as you can see in the picture. And then again, if we will wrap the cable into a coil, the magnetic field would become even stronger. Now, what if a second coil is placed in a close proximity to the first coil? The magnetic field of the first coil will induce an EMF in the second coil according to the law of electromagnetic induction. Here, I'm assuming that you're already aware of this law. The magnetic force will push and pull on the electrons in the second coil, forcing them to move. The magnetic field in the first coil is continuously changing its intensity as well as the polarity. The change in the polarity and the intensity of the magnetic field induces an alternating current in the second coil with the same frequency. Now the problem with the older setup is that a lot of magnetic field is wasted. All the magnetic field lines do not reach the second coil. Therefore, what we do is that we use a ferromagnetic material such as iron between the two electric circuits. This magnetic material guides the magnetic lines to the secondary coil more effectively, which makes the transformer much more efficient. Therefore, transformer consists of two electrical circuits and one magnetic circuit, and these two electrical circuits are connected by one common magnetic circuit. The magnetic circuit is called the core of the transformer. It is usually made of laminated silicon steel. Therefore, the process of inducing EMF in one coil by changing the current in another coil is called the process of mutual induction. The transformer works on this principle only. Now, taking a quick recap, a transformer is made of a transformer has two coils, the primary and the secondary. The primary is connected to the mains, or we can say to the supply voltage, and the secondary is connected to the load. In between the two coils, there's a common magnetic circuit, which helps to strengthen the magnetic field. The magnetic field induces an EMF and hence a current in the secondary coil. Without any change in the frequency. Now, whether the secondary voltage is more or less than the primary voltage depends upon the type of transformer we are using. The working principle is same for all the types. The idea of step up and step down transformer will be clear to you in the next video. So before learning about step up and step down transformer, make sure that you have very clear idea about the working principle of the transformer. So keep watching. Thank you.